Hi, this is Marcin and Andre again. In this video we will show you how to, with the help of Service Domain Manager 1.0 Update 3, add cloud elasticity to a grid engine service. We will continue to demonstrate the setup and installation with the system from our previous video, Grid Engine Adapter Installation video. As we can see here, our grid engine cluster used all of our local resources, and it is still not enough. First thought is that we should extend our cluster by adding new physical hosts. That is true, but additional hosts equal additional costs. We need to buy them and maintain them. It all costs money. What we can do instead is to use a cloud service and compute host on demand solution. With a connection to a cloud service, we can scale a cluster size beyond the limits of our local data center. Couple of words about basic requirements for a cloud service adapter. As a cloud service, we will use an Amazon EC2. From the EC2 side, you need credentials to access your account. You need to have security group with configured ports for SSH and VPN. Keeper file has to be created for passwordless SSH access. As the last thing, you need to install EC2 tools on the master host. On the master host, OpenVPN should be installed also. Cloud adapter requires Java in version 1.6, internet access, and correct time set in the system. Before starting with the cloud adapter installation, you need to ensure that you have following configuration data available. From EC2 side, you need to know the location of the Java home directory for EC2 tools, your security group name, location of the keeper file, user certificate file, and user private key file. Path to the directory where EC2 tools are installed. We prepared for you MI instance with the ID given on the slide. Type of the instance is m1.small. You need to know also where are the binaries for OpenVPN and its configuration directory. The Service Domain Manager manages only resources that are known to the system. The number of the resources started in the system should be greater than 0. Please notice that the cloud host is always started before the request. The amount of cloud resources offered by the cloud adapter can be configured with the min-max amount configuration. Whenever the amount of resources drops below the minimum value, new cloud resources are automatically started up and become available. If the amount exceeds the maximum value, the excess of resources is automatically returned back to the cloud. Since the startup of new cloud resources is triggered by the undercutting the min amount, this value has to be at least 1 for a dynamic balancing. The resource amount optimizer tries to readjust the resource amount with configured time interval. A high min value decreases the average response time to resource requests, as adding new cloud resources is a time-consuming operation. But keeping additional spare resources idle in the cloud adapter will increase costs. By default, EC2 allows you to use a setup of up to 20 cloud hosts. We introduce our own additional configurable host limitation to ensure that no more than expected resources will be present in the system. To install the Grid Engine Service Adapter, we log in on node 0 as the root user. Let's check that the Grid Engine cluster is running. We source the cluster configuration. As you can see, the cluster is currently running but empty. Let's continue with the pre-installed SDM system. We will switch to the distribution directory and check the installation. Our system MySDM is installed. The show resource command shows the complete set of 5 host resources. All resources are currently located in the spare pool. As we will see with the show service command, 2 services are managed by SDM, a spare pool and a grid engine service. We will now add a cloud service adapter with the name cloud adapter to the local host node 0. As we want to start the adapter directly, we add the -start option. Executing this command will automatically open a configuration file in the system editor. Here we need to type OpenVPN bin directory location. Now, the path to the OpenVPN configuration directory. Here we need to type Java home directory. AMI that we plan to use, EC2 security group. Path to the EC2 keypar file. Keypar file name, EC2 user certificate file location, EC2 user private key file location. And as a last thing, path to the EC2 tools directory. The add cloud service command will report that cloud adapter has been added. Let's check if it has been started too. The show service command will report that cloud adapter is running, as well as G adapter and spare-pool. The show resource command will show that the cloud adapter is running and one cloud host is assigned to this service. We will submit 5 long-running sleeper jobs to the grid engine cluster. All local resources from SparePool service are now assigned to grid engine adapter. As we can see, the jobs are now executed on these hosts. Now we will submit another sleeper job. The job is pending in the pending queue. With the show SLO command, we can see that GAdapter sent another resource request. Cloud host was already moved to fulfill the need, and the pending job was scheduled on that host. Just after one cloud host was unassigned from Cloud Adapter, another cloud host was started. We speed up this process for the video purposes. Normally start of the first host takes around 10 minutes, because it contains VPN server. Start of the next host takes around 2 minutes less. In the meantime, we deleted all long time running jobs in the cluster. Resources are coming back to their owning services. We don't need cloud resources anymore. To terminate the cloud instances, we need to change the cloud adapter configuration. The min-max value determines the amount of cloud resources available in the cloud adapter. By default, the max value is set to 5. It means that at most 5 cloud hosts can be started by the cloud adapter. The min default value is 1. We will set the min and the max value to 0. The cloud adapter will start now to terminate the cloud host instances. Let's summarize what happened in the SDM system. At the beginning, the cluster was empty and no job was queued in the pending queue. 5 resources were located in purple service and 1 resource is present in started cloud adapter. We submitted 5 jobs that queued up in the pending queue, and the max pending job SLO requested 5 host resources with the urgency of 10. The requested resources were moved from the purple into the grid engine service and were added to the cluster. The pending jobs were scheduled on the hosts and the pending queue became empty. As a next step, we submitted additional job to the cluster. There is no free host remaining in the cluster, so max pending job sent another resource request with urgency of 10. Since there weren't any local resources in the purple that could be used, SDM took cloud resource from cloud service and added to the cluster. Pending job was scheduled on the cloud host. Max pending job SLO wasn't sending resource request anymore. Since the cloud adapter was configured in a way that min value that represents the minimum number of cloud hosts present in a cloud service was set to 1. A new cloud resource appeared in the service. After some time the jobs were finished, so their usage dropped from 10 to 0. The resources were moved back to services. Cloud service had permanent request SLO set up with the urgency of 2, but it was only interested in its own resources that were marked by the flag owner equal cloud. So he just got 1. The rest of the resources went back to the purple service. As a last thing, we have changed the cloud adapter configuration in a way that we set the min and max value to 0. The result of this action was that all cloud resources were terminated on the EC2 side and cloud service was shut down. Finally, you may want to check the grid engine and SDM product pages at www.sun.com/software/sge and the online documentation at wikis.sun.com/display/grid engine. Thank you for watching this video.